Determine the number of protons, neutrons, and electrons of the following ions, and some of them are actually atoms because they are neutral. Write the correct name of the atom. And in parentheses, it tells you the name dash the mass number would be the correct name of the atom or ion. Fill in the complete standard nuclear notation, complete symbol, box. That means you'll have the symbol, you'll have the mass number, the atomic number, and the charge all around the symbol. So if I was doing calcium, the first one here, with the provided information, it tells me the mass number. Well, I can complete the name, then I can put dash 41 there. That's easy enough. But I only have the mass and the charge. What additional information can I retrieve from my periodic table? The protons, because calcium's atomic number happens to be 20. So the atomic number is always the proton number, and it always identifies the element for us. So if I go to my periodic table, look up calcium, I can find that it has 20 protons. From that, I can also identify my neutrons, because now that I have my mass number is always going to be the protons plus the neutrons, right? Can't I not figure out my neutrons? It's a simple subtraction problem. All I have to do is take my mass number, subtract my protons, and I will get my neutrons. So 41 minus 20 is going to give me how many neutrons? So I have 21 neutrons. Now, last but not least, which is always the hardest one, so I would suggest that you wait till the very end to do this part, is figuring out the electrons. The charge here is a what? +2. Did I gain or lose electrons?
Lose.
Positives always mean I lost electrons. Why is that? Because that seems opposite, right? You're adding stuff, so shouldn't it be positive? No. Let's think about what an electron is. What kind of charge is on an electron?
Negative.
A negative. So if you get rid of negative numbers, shouldn't you become more positive? If you're getting rid of negatives, shouldn't you become more positive? Yes. So if I'm at just a regular atom of calcium, where I haven't gained or lost any electrons, how many electrons would I normally start with? If I have 20 protons, I need to have how many in order to have a charge of 0? I would have 20 electrons. But in this case, I lost 2. So how many total do I have? I now have 18. Let's think about this. 20 protons, 20 positives, 18 electrons, that's 18 negatives. So I have 20 positives, 18 negatives. What's my overall charge going to end up being? A +2. And that's where that comes from, because I have 2 more positives than I do negatives in the atom. Now, for the complete symbol, I'm still not done. Let's finish this. Ca. The mass number should go up here in the upper left corner. The atomic number, or protons, need to go in the lower left corner. And the charge goes where?
In the upper right corner.
Upper right corner to complete the symbol. That's what I want there. All of that needs to be done in order to get full credit. Now, yes, pick another one. Somebody would like to pick one? Chlorine. Let's look at chlorine. All right. Chlorine, it tells you the mass number. That's going to be dash 37. What's the next piece of information I can look up? Protons, which happen to be 17. Now I can figure out my what? 37 minus 17, the mass number minus the protons gives me 20 neutrons. Good. Now, what does a -2 charge tell me about the electrons?
We're adding 2.
You're gaining 2 electrons. You gain 2 extra negatives here. So what do we normally start out with?
4, 17.
17. And if we gain 2, we're going to have
19.
19. Now, so just so everybody's clear, if we have 17 protons, 19 electrons, that means we have 17 pluses, 19 minuses. If you were to add those together, you would get a -2 charge. Remember, you can always write the charge with the number first, then the symbol, or you can write the symbol first and then the number. So you might see it written as a 2 minus or a 2 plus, just so you know to remember that. Now for our complete symbol. We have chlorine. We have the mass number. We have the protons. Protons here, 17, thank you. And we have the charge. Now this side gives you the standard information for each one exactly the same. On the other side, though, it becomes more of a puzzle, because you have to kind of search around and figure out what they give you. So, question. If there is no charge, say for instance, for say argon. Good question. This is a good question. So I'm going to kind of go quickly on this one. Argon, mass is 36, but argon's proton number is 18, right? 18 on the periodic table? Correct me if I'm wrong? Okay. So then this is going to be 36 minus 18, which happens to be 18 neutrons. Says a charge of 0. So if I'm equal, that means if I have 18 protons, I must have 18 electrons. Now, when I'm writing my symbol, and this is where the part comes to play, argon is AR. The mass number still goes up here. The proton number still goes here. But we do not need to fill in anything for the charge. You don't put a 0 there. When there is nothing there, we assume 0. Okay? Yes? Sure. The electrons are all about the number of positives and the number of negatives, because each one that's a positive proton, for every one of those, if you have one electron, one positive, one negative cancels out to 0. Right? So if I had 18 protons, that's 18 positives. I have 18 electrons, that's 18 negatives. Those add up to 0, right? Positive 18, negative 18 adds up to 0. However, if you go back up here to the chlorine example, where it told me that it was a -2 charge, I start with 17 protons, and I start with 17 electrons if I'm neutral. But since I have a -2 charge, that means I've gained 2 negatives. So I've added 2 electrons, because the electrons are the only thing that can be added or subtracted here in terms of the charge. So I had 17 positives, but now I have 19 negatives, so I end up with that -2 charge. That's where I got 19 electrons. Well, let's do some on the back to it, and we'll keep working through the electrons. So aluminum on the back was asked for, so let's do aluminum. Well, aluminum symbol is Al. Still going to do my complete symbol. What do I know here? The only thing I know is the neutron and electron number, so I need to figure out my protons. What's aluminum's atomic number? 13. So I have 13 protons. Now I can figure out my mass number, because what do I need to do here? Mass number. How do I figure that out? Adding the protons and the neutrons are going to give me my mass number, which happens to be 27, correct? All right, now I can look at the charge. I have 13 protons. I only have 10 electrons. Did I gain or lose electrons? I lost 3, because I normally would start out with 13, just like the proton number. So if I lost 3, what would my charge be? Positive 3. Good. So this would be a 3 plus or plus 3, doesn't matter. Now to fix this over here, we have aluminum 27. We put the 27 in the upper left corner, the 13 down here, and the plus 3 over here. Finish it off. Make sure you complete that symbol. Make sure you complete the name. So I'll do 2 more examples for anybody who would like to see them. All you have to do is ask. Phosphorus all the way at the bottom. Do tell me the atomic number of phosphorus.
15.
It is 15. So out of the provided information now, I know I have 15 protons, I have 15 neutrons. What can I find out from that? The what? Well, I can figure out the electrons too for the information provided, but from the protons and neutrons, I can figure out the mass number. So 15 plus 15 gives me
30.
Good. Now I can look at the electrons. I normally start with 15, but I have a +2 charge. That means what happens? I lost 2. Very good. So my electron number would be 13. Now let's complete our phosphorus -30. So now we have P. We have 30, 15, and +2. One more. Anybody?
Did we do the one below aluminum?
The one below aluminum, sure. Because that's another phosphorus. It's a different phosphorus, but it's still another phosphorus. How do I know it's another phosphorus?
The proton number is
The proton number is 15. This is an isotope of the other phosphorus. Now, 15 plus 16 gives me what for my mass number? 31. So, this one is -31. Can't fit it in the box, but. Alright, now, looking at the electrons and the protons. I normally start with 15 electrons, but I have 18 now. What does that tell me? Gain 3, so my charge is -3. Now for the symbol, another P, 31 this time, 15, and it is a -3. So, we have isotopes here, we have ions here. This one had a mass of 31, the one at the bottom of the sheet had a mass of 30. Now remember, each one that we're doing on here is one individual atom. Lots of people like to confuse that with the decimal number on the periodic table. That decimal number represents all of the atoms of that element. That's a weighted average. So like for instance, phosphorus is 30.97 up there for its average atomic mass. That means that if you added up the masses of every single phosphorus out there, that's going to be what the average is. So one particular phosphorus, though, can be at 30. Another one can be at 31. There might even be some that are at 32. It really does depend on how many of each mass out there, that's how we calculate that weighted average.